everybody, this is Miss Bufford and this is video 4 in our thermochemistry unit, and in this video we're going to talk about specific heat. Your learning goals for this video are to be able to calculate the specific heat of a substance or the mass, temperature change, or heat. So what is specific heat? The specific heat is the amount of energy that's required to raise the temperature of 1 gram of a substance by 1 degree Celsius. Every substance is going to have its own unique specific heat value, and this means that every substance absorbs thermal energy differently. Some things require a lot of thermal energy in order to change their temperature, and others just require a little bit. So some examples of how specific heat influences a substance's properties would be that some pans that are used for cooking are made with copper because it has a low specific heat value, meaning it just takes a little bit of energy to change the temperature of that substance. And this makes it a really good thermal conductor because it's able to absorb lots of energy, and it changes temperature quickly. It also heats very evenly. Another example of how specific heat can influence a substance's properties would be for water. Water is a really good one. It's got a very high specific heat value, and this makes it good for putting out fires because it has to absorb a lot of energy before it's able to evaporate. And so water is able to get in there and smother a fire before it evaporates to help put the fire out. All right, so now we're going to talk about specific heat calculations. When we do these calculations, we're going to be using this equation over here. Q equals mass times the specific heat times the change in temperature. In this particular problem, Q represents an amount of heat energy, and we measure heat energy with a unit called the joule. Okay, and then mass in this calculation will always be in units of grams. And our specific heat, which is C, is going to be we're going to have units of joules per gram degrees Celsius. So joules over grams and degrees Celsius. And then temperature change, if you'll take a look at this little triangle here, that just means that whatever comes after it is changing or experiencing a change. And in this case, we're talking about temperature. So our problems, as you'll see in just a minute, are not always going to give us our change in temperature, but they'll give us a final temperature and an initial temperature, and we'll have to figure out what that change was. And so in order to do that, we have this little other equation right here that we can just substitute in for delta T in that equation sometimes if we need to. And that is just that the final temperature minus the initial temperature, okay? It's also important to note for some of the calculations that you're going to be doing that if our delta T value is negative, that means that the system is losing heat. And so our Q value will be negative because that heat is leaving the system. If our delta T, or our change in temperature, is positive though, that means our system is gaining heat energy, and Q will be positive because heat is flowing into our system, okay? These are just some other values to keep in mind with some of the calculations that you'll come across in your quiz. We've got a conversion here for kilograms to grams. Another unit commonly used in thermochemistry is the calorie. This also measures heat energy. And this is just a little conversion right here to show you how many joules there are in 1 calorie. And then these are our temperature conversions. So this is how to convert, this first one is how to convert from degrees or Fahrenheit to the Celsius scale. And our second one is just a reminder of how to convert from degrees Celsius to Kelvin if we needed to do that. And then our last little conversion factor is that 1 kilocalorie is equal to 1,000 calories, because some of the problems that you might come across in your quiz will give you calories instead of joules, okay? Okay, so our first example says that an ancient gold medallion absorbs 576 joules of energy when it's heated. This causes a temperature change of 25 degrees Celsius. What is the mass of the gold medallion? And so before we get started, I have some information over here. I have this table of specific heat values, because remember that every substance has its own specific heat value. They're kind of like, you can think of them as like a little fingerprint for that substance, okay? Then I've got my specific heat calculation, my formula that I'm going to need, and then there's just some extra information just in case I need it, okay? So the first thing that I want to do is I'm going to take all the values that are listed in my equation, and I'm going to make a list of them. So I have Q, I have C for specific heat. Remember, Q represents the heat added or taken away. And then I have mass, and then my change in temperature, okay? And so the first thing that I want to do is read through this problem and list out all the information the problem's giving me. So it's telling me that there are 576 joules of energy that are being absorbed by this gold medallion, which means that gold medallion is going to be our system, and it's pulling in thermal energy. So that means our Q value is positive, so 576 joules of energy. And then our C value, that represents our specific heat. And if we take a look over at this chart, the metal that we're dealing with is gold. And so we're going to use this value for the specific heat for gold, which is 0.129 joules per gram degree Celsius. And then it's asking us to calculate the mass, so that's our unknown. And it's telling us that the temperature change was 25 degrees Celsius. So the temperature increased by 25 degrees Celsius, 25.0 degrees Celsius. So there are the variables that I'm going to need for this equation. The next step is to take this equation over here and rearrange it so that we can solve for our unknown value. So we want to get our unknown value isolated, or variable isolated, on one side of our equation. So I'm going to go ahead and rewrite this. Q equals Cm delta T. And what I need to do is I'm going to divide both sides by C to cancel C out. And then I'm going to divide both sides by T, or delta T, to cancel that out. And so my new equation is going to be Q divided by C and delta T equals the mass. And so let's go ahead and plug our variables in. So Q is 576 joules of energy. C is 0.129 joules per gram degree Celsius. And my delta T is going to be 25.0 degrees Celsius. And so let's just go ahead and take a look at how our units are going to be canceling out. I have down here in the numerator, inside that larger denominator, I've got a joule, so that's going to cancel out. Then I've got degrees Celsius in the denominator of this unit right here, and degrees Celsius here. That's going to cancel out. And then that's going to leave us with units of grams. And so then if I perform this calculation in my calculator answer is 178.6 grams. But I can only have, it looks like 3 significant digits, so I'm going to round that to 179 grams. And there's my final answer. All right. All right, our next example says an unknown metal with a mass of 54.0 grams required 773 joules of energy in order to change its temperature from 63 degrees Celsius to 100 degrees Celsius. What is the identity of this metal? All right, so now we're calculating specific heat, because that is the only way that we can identify this metal given these specific heat values in this chart right here, okay? So what I'm going to do first is I'm going to go ahead and I'm going to list out my variables just like I did before. So I have Q, C, mass, and then this time, because in my problem I'm given an initial and a final temperature, it doesn't tell me how much the temperature changed. I have to calculate that. And so what I'm going to do is I'm going to write my temperature initial and my temperature final. Okay, and so let's go ahead and read through this problem and plug in this information that I have. So it says an unknown metal with a mass of 54.0 grams is required 773 joules of energy in order to change its temperature from 63, so that's our initial temperature, degrees Celsius, to 100 degrees Celsius, which is our final temperature. And you can see we're calculating specific heat, and once we know what the specific heat value is, we'll be able to look over at this table and identify what the substance was, which metal it was, okay? And so what I want to do is I want to take this equation and rearrange it to solve for C. So I have Q equals specific heat times the mass and delta T. And so I just need to have C by itself. So I'm going to divide both sides by mass and delta T. And that'll get rid of them on this side. So I end up with Q divided by mass and temperature change equals my specific heat. All right, and since I'm not actually given delta T, I'm going to go ahead and expand this part of the equation. So I have Q divided by mass, and then my delta T is going to be, remember we said that's our final minus our initial temperature. So temperature final minus temperature initial. And now I just need to plug in my variables. So I have 773 joules divided by 54.0 grams. Kind of running out of space here. And then my final temperature is 100 degrees Celsius. And my initial temperature was 63 degrees Celsius. Oops, that's degrees Celsius. All right, and then if I plug this all into my calculator, I end up with a value of 0.387, okay? And that, my units are going to be joules over grams degrees Celsius. So this right here is my specific heat value. And let's take a look up here at the specific heat table and see if we can identify this metal. And it looks like this is going to be copper because that is the specific heat value for copper. So copper is the answer, okay? All right, and here's our last example. This says a 3.76 gram of ingot of silver metal absorbs 48 joules of energy. What is the final temperature of the metal if it's initially at 47 degrees Celsius? So I'm going to use my equation again. And so the first thing I need to do is I'm going to list out my variables. So I have Q, C, mass, and temperature change. And because I'm calculating my final temperature, what I need to do is I need to list out my temperature initial and temperature final, because it's giving me my initial temperature and it's asking me to find my final temperature. So let's go ahead and read through this problem and plug in our information. So I've got 3.76 grams of silver. So my mass is going to be 3.76 grams of silver. And my heat, so 48 joules, was absorbed by that silver. And the specific heat value for silver, I'm going to look over here at this table, is 0.24 joules per gram degrees Celsius. And my initial temperature was 47 degrees Celsius. And so this is my question mark right here. And so what I need to do is I need to solve this equation for my final temperature. And so let's go ahead and see what that would look like. So I'm going to go ahead and write this equation out. Q equals cm, and instead of using delta T, I'm going to expand that, and I'm going to use this right here to do that. So I'm going to write my temperature final minus my temperature initial, and that is going to allow me to calculate my final temperature right here. Okay, so let's go ahead and rearrange this so we have final temperature by itself. So what I need to do is I need to divide both sides by cm, by specific heat and mass. Okay, that gets rid of cm on this side, but because I'm subtracting my temperature, my initial temperature from my final temperature, I need to add Ti to both sides. This is getting kind of messy, so I'm going to rewrite this down here. So I have my Q divided by Cm plus my initial temperature is going to be equal to my final temperature. Okay, so now let's go ahead and plug in all the values. I have 48 joules divided by my specific heat, so 0.24 joules per gram degree Celsius. Then I'm going to also divide that by 3.76 grams. Okay, oops, I need to add my temperature. So I'm going to add my initial temperature, which is 47 degrees Celsius. And if I plug this all into my calculator, I end up with 247 degrees Celsius as my final temperature. Thank you for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.